Here we have a system of equations that we are going to solve using the method of substitution, and it is a little bit more complex than what we've seen so far, in the sense that we have a fraction appearing over here in an expression for y. So what I'm going to do is I'm going to substitute the y in the second equation with the expression for y in the first. Now my rationale behind choosing that is because I already have y isolated in the first equation. Let me label them here. I'll label this equation 1 and this equation 2. So again, y is isolated as a variable in terms of x, and I'm going to replace the y in the second equation with the equivalent expression in terms of x. So what does it look like? Well, I'm just going to copy it, 3x minus, but instead of 4y, I'm going to replace that y with 2 over 3 x plus 6, close bracket, plus 15 equals 0. So this here is just y in terms of x. And at this point, I can continue my work by expanding, collecting like terms, and solving for x. So let's do that right now. I'm going to multiply this negative 4 into this set of brackets, both terms. So I have 3x minus, so negative 4 times 2/3 is negative 8 over 3x minus 24 plus 15 equals 0. Let me collect now the fraction of the x terms together. Remember, that's a fraction, 3 over 1. I need a common denominator, so I'm going to multiply this denominator by 3 and this numerator by 3 because I want these to match up. So my next line is 9x over 3 minus 8x over 3 minus 9 equals 0. Again, I just combined this negative 24 and positive 15 to give me negative 9. These two fractions now, they do have a common denominator. I can add them. So the 9x subtract 8x gives me 1x, or just x, over 3 minus 9 equals 0. And now I'm good to solve for x. So I'm going to bring the 9 over the other side of the equation. I'm left with x over 3 equals 9. And I can multiply this 3 by the 9, or you can just think of multiplying both sides by 3. Either way, the result is the same, and that is x is equal to 27. So there's your x value of your point of intersection. We need to solve for the y value. Now, you may have learned that it does not matter which equation you choose, which initial equation you choose to plug your value into, but one suggestion would be is to pick the equation that requires the least amount of calculation, or the equation that already has the variable you want to solve identified. And in this case, it would be y. Okay, y is by itself. If I give that equation an x value, I can solve for y. So let me do that. I'm going to replace the x value with 27. So I'm going to have over here, this equation I'm going to use, y equals 2 over 3 times 27 plus 6. How many times does 3 go into 27? It goes 9 times, so 2 times 9 is 18, plus 6 gives me 24. So my point of intersection in this case is going to be 27, comma 24. My point of intersection.